Okay, okay, okay. Morning, everyone. I can see that maybe football has done its effect. Okay, I've also heard by the score and about the score. I can't believe it. So we continue this morning with quantum finance. Please sign the sheet and the speaker. The podium is yours.
Thank you, Anna, for the introduction. Should we turn off the light? Maybe it's... By the entrance. And the entrance.
Right to right.
Yeah. Okay, maybe it's better. Yeah. So, good morning, everyone. Maybe you guys are a bit shocked with the score as well. I made a comparison with football, and I said that we always forget that the future can bring the E situation, the very unlike situation. Argentina losing to Saudi Arabia is a good example. So before I forget, I'd like to post this postdoc opportunity in Maceió. The field is quantum optics. It's for young doctors. You have to have concluded your PhD in this range. The deadline is very short. So if you are interested, please contact, send your CV or LATS if you have this Brazilian online template to one of those guys. The opportunity is for 2 years, and the salary, I believe it is standard Brazilian postdoc, 4,100 reais. So those two are nice guys to work with. I'm not sure if it's for theoretical or experimental position. They are both. So yeah, if you're interested, please text him. So I keep Marcel here just to tell you that it's a good place to work. So you are not going to be this close to the beach. The university is very far away. Maybe it's closer to São Paulo than to the beach. But okay, you can live here and work there at the university. So the outline is the following. I will give some more touch about finance, something that I promised to tell you guys. I will revisit some ideas of portfolio and portfolio optimization. I did this comparison with SOC Squad. Today is a good moment to discuss it. Then we come back to KAOA and the implementation, and to be complete, I have to show our results, okay? In the end, I give some final thoughts. So, I told you that the future can be really unpredictable, and in terms of the portfolio management, is this that you have to have in mind. So the risk come with more difficult to predict. So your distribution is wider. So your distribution is much more difficult. So have this in mind that when you are increasing the risk, what you are really increasing is your understanding about the future. So so I repeat this figure just to tell you that maybe if you have like contracts, you are not buying stocks, but you are acquiring bonds. So you have a contract. You sign a contract saying that, oh, you pay me this interest rate for this period of time. So you have a contract. For example, when you are in the stock market, you have no guarantees that you're going to have a profit. You can even have some losses. So that's the key idea of the risk involved in your investment. So I told you that I would show you this capital market line. So in the very beginning is this thing that you think that is your risk-free investment. So money market is like very short treasury bonds. So these bonds that you can acquire from the government or for even banks, but for the very short period of time, 3-month bond, for example. So then, okay, to get something riskier, we request increase in the profit. So this is the idea. So if it's paying so high, you go to the stock market only if they give you like a good, if they add a lot of return. So this is the point. Sometimes this money market is so slow that you are forced to beat inflation, for example, to move on. So that's the point. So this is the capital market line that I told you guys I would show you. And in portfolio optimization, what do you want? What do you need? How do you add value for your portfolio? 2 ways. With the same risk, you can get an increase of return. This is I think that you would go more aggressively. I want more return. This is the approach you can do. So this is a benchmark here. It can be the index market. Then you want to beat it, okay? But you can go in a more defensive way. So I want the same return of the benchmark, but with less risk. This is also a good approach. And this approach is the one that will help, that will make you survive, because the less you lose is the better. I mean, this is a personal point of view approach. Okay, we are good so far? So those are the important thoughts about the market. If you are interested and for this kind of non-technical reasoning about the financial market, you should read this book, Howard Marks, The Most Important Thing. He's an asset management at Oaktree in US. I mean, you will profit a lot by reading Howard's books before you invest. Okay? We are good so far? Any questions? Okay. So let's go back to where we stopped. I showed you that we picked some stocks, but before I'd like to make this comparison. So the point is that now in the World Cup, you have to pre-select some players, and then before the match, you have to select 11 players to start the match. So in some sense, there is this nice comparison with soccer and stock management, because you have to be prepared for any situation. You have to be prepared for eventualities. And you have more or less the same squad from the beginning to the end. You are not randomly picking and changing players. So the key idea is that most of the players, or most of your assets, are on the field for the whole match. You can make few changes, but in the broad view, it's the same guys. The same squad, or you can think portfolio, have to play defensively, and they also need to attack. So your portfolio must be prepared for eventualities. And collectively, they have to score goals and to defend against losses, to defend against goals. So I think this is the best analogy that I can bring currently. And the example that we gave here, that let me review this. We selected 4 Brazilian stocks, and then we compute this annualized return. Then you have the covariance for the same period of time. And then we use this to classically retrieve the efficient frontier. So this is what we have done. And I showed you also many portfolio. This is the one with lowest risk. This is the one with the highest return, and so on. This is the best one, the best ones compared with the risk-free that you imagine you have. Okay? And then what we did afterward, we inserted this in KUA. And yesterday I showed a very black box implementation of KUA. So the one you can use with API from Qiskit. So I forgot to put some exercise because I think you have a lot to do, but if you are really interested in quantum finance, you should change in that notebook the backends. So you can put noisy backends. It's still simulation, but with noisy backends. Or you can also put real backends. You can choose, for example, one of IBM real quantum compute. With this number of assets, you can run for free. You enter a queue, but it will run. Then you can compare how good your result in a real quantum compute. But in our case, I told you that we wanted to make an all-Brazilian approach, all Brazilian in some sense, that we use the simulator by Atos. Atos is a French company, based in the US, but French company. And they have a full ecosystem for quantum computing. By full ecosystem, they have our software, our API, and also our simulator machine. So this one here, it's in Salvador. We went there, and they have this, and they have an API to access this. And then we use the quantum simulator by Atos to implement our KUA. So, to the sake of completeness, I have to tell you what our results. So just before, let me show you where you can see this. So I'm going to tell you the results we had due to this notebook here. So yesterday I showed you guys that it's kind of random. If you change the seed, you change your result, so that's not good. So what we did, it was try many times and take an average. And let me show you what you have did here. The main idea is to understand the convergence of KUA. So how many layers should I put? How many layers is the best one? Does your answer is better with the larger number of layers or not? That was the point. And this is what we get after we put 20 layers. And then we can say that you have an answer here, because your ground state reveals the best solution for you. If you remember, we were looking for the best solution to be 1, 0, 0, 1. So here you have a real gap between the most likely and the others. The others is around 0. So this is our result for 20 layers, okay?
Just a quick question. So, do you mean that the kind of ground state is kind of a superposition composed of all these eigenstates?
Mm-hmm.
The 1, 0, 0, 1 is just
The amplitude.
biggest amplitude, right?
Yeah, you can think that. And how was the convergence? See, this is this probability, right? In function of the number of layers. So if you have a fewer number of layers, and they claim in the original papers that, okay, you will converge to the solution even with p equal 1. P is the number of layers. In fact, he is not 0, it's 1. We should have changed the axis, so 1 and 20.
What exactly do you mean by layers? The number of seats?
No, the layers is the number of, how many times you will repeat this X structure. This one layer, now 2 layers, and so on.
But is it for the same seed?
For the same?
It's the same seed?
Yeah, in this case we made like, you can check in the code, but I think we tried 20 layers. 20 seeds, and take the average.
And what does exactly the seed provide for the system?
The seed is the initialization of those layers. You see here, how you initialize. So it's not going. So you have a couple of parameters here and how you initialize.
Oh, okay. The seed is part of the method of using a seed.
Mm-hmm.
It's part of the machine learning method.
Yes, yes. There is some approach to the best, how you best initialize your code. It should be random, should be, or what kind of distribution should you sort on. But the best one so far is initialization. But in the end, you can fix the seed and guarantee reproducibility. But you cannot have the best solution. So in some sense, you have to take averages over many seeds.
Another question, the system is 2 qubits?
4 qubits. One per stock. One per stock. So, does it make sense?
Those sort of states, 1, 0, 0, 1, are in 2 qubit states?
No, I didn't get the.
When you have 2 qubit states, isn't the number of digits you have?
Now you can have. This is the full combinations, possible combination. But the best solution that we are looking for is encoded in this 1001. And I don't know if I repeated here. Yeah, for one in the first is if you include or not this one, include or not this one, 0, 1, include or not this stock, 0, 1, and the same for this one. So in our case, this is the point. It takes time to run for each seed and to make like the average. So what we want to show is that the convergence occurs, that it's a good practice to include more layers. Okay, but I mean, this is average. Then you can see sometimes that you increase the number of layers, the result is worse, not better than you expect. So this is the point. You cannot have a convergence in KUA, but it's heuristic yet. So the best number of layers you have to try. This is a hyperparameter. You have no method that will optimize a priori for you. So you have to try and the error approach is the best one. Or you can like do a brute force as we did, like compute many and take averages. That's the point. When you are dealing with heuristic methods, and this is the problem that for us in science, we can find the friction when you bring these heuristic methods. in some sense, to academia, because people can always ask you, and you cannot give a satisfying answer. They can always ask, how can you guarantee that you are not stuck in a local minima? You cannot tell them convincingly that you are not. That's the point. That can be a better solution. Yeah, that can be a better solution. So in academia, it's kind of not good. But imagine this in companies. I saw in the beginning Gmail classifying spam and not spam. I'm this old. I get an invitation to get in Gmail. Maybe you guys don't know, but you should to have an invitation to get to Gmail. And then in the beginning, they missed a lot. Like, this is spam. Oh, this is not spam. This is my mom talking to me. And I had to go there and say, this is not spam. This is just my mother, in some sense. But now, Google is this classification oracle that they can classify things so well. And I have a joke that the engineers, the machine learning engineers in Google, they are not, oh my God, is machine locked in a local minima? They are not asking this question because they have a precision close to 100. They get the thing done, they get the things well. So in academia, you have to know that this is an heuristic method. But if you remember Raphael's talks, he talks about many demonstrations of artificial intelligence that we made together. The machine could retrieve the phase transition for a complicated Hamiltonian better or so close to Landau methods, for example. So an analytical method was, how can I say, was tested against an heuristical method. So if you want to find the answer, why not try an heuristic method? So why it have to be analytical? And is analytical the best approach? So I'm okay with this approach. It's the kind of things I'm doing for more than 4 years now, and I'm okay with a heuristic approach. So, but have this in mind. Everyone can ask you, is this the ultimate best solution? And it may be you are obliged to say no, okay? But it gets things done. And the convergence of the energy was also, I mean, related with the best value for the probability. So we decided to stop here in 20 layers. And this is kind of things that we can do. If you don't want to code more, you can just go in the first notebook and change the number of layers and test. And I will show, I go back to the code and tell you how you can do that. You can do this, okay? So far, so good? Yeah? Okay. So the implementation of KOA is in this code I showed you guys. And I will make, I will let you guys with this exercise. Okay, if you are really interested in quantum finance, you should do this. Try a full KOA implementation. My implementation, in fact, it was done mainly by the guys at Senai Symantec. The guys near the simulator, they made most of the code, practically all the code. You can try, go there, check how it is in KLM language, and do the Qiskit implementation. So I will give you an idea how you can code it here, then you can copy this code and try as you wish, and make our implementation of KUA. Then you can put a loop in the number of layers. Here we have 2 layers. Then you can try as you wish. So I will give you a quick answer to this exercise here. So I will send this code to send this presentation to the guys in the secretary, and they will put in the site. But more than this, why not you try many other quantum framework. So you have Qiskit, but never, I wouldn't say that Google should be relegated. So every time I'm doing this, I have, why I'm not doing it in Google language. So in some sense, I believe that Google will also dominate this field in some sense or in some field. Then you can try also PenLane or D-Wave. Why not? So the code is not that different. The syntax in the codes are not that different. Maybe C0 is uppercase in one language and C0 is not uppercase in other language. So if you implement in one, you can implement in many. So if you are really interested in this, why not to try all of them, most of them? PenLane is, for quantum machine learning, in my point of view, it's the dominating framework. So if you want to be prepared, if you want to try to get some jobs or things like that, I would say that those guys should be in your skill set of abilities, okay? So for conclusions, as I told you, KOA is good for NISQ era. It's not, as we discussed, it cannot be so scalable, but if your problem is small, you can fit in few qubits. That's good. You should try this approach. I mean, I think I gave you a nice approach of how it belongs to this variational, more broad variational approach where you parameterize your state, then you define some energy or cost function as you wish, and then the answer is encoded. The best answer is encoded in your ground state. I think that you guys probably from physics schools, you have some connection with this yet. Maybe you didn't connect the points, but now I think you are okay with the idea. We have active field. I would say that if quantum winter is really common, as we discussed in the roundtable, maybe quantum finance is the one that will suffer the less. Because I will give some final thoughts about that. We have many things that we can achieve with the simulators. So even if a quantum winter is coming, I believe it's a good thing that it's an area that will suffer less. Okay, you can even use it to solve like hard problems. Optimization, combinatorial optimization is one of them.
What do you mean by, what do you mean by warm start?
Yeah, to be honest, I didn't.
Warm start.
Yeah, to be honest, I didn't know exactly because this I stole from my colleague. This slide, but I remember his talk, and I will guess the answer. This is just a guess. Is in this kind of how you initialize your problem. So it doesn't need. You won't have a hard time to dealing with initialization. This is a real problem with machine learning. When you have big machine learning, the convergence is maybe difficult. So, but it's a guess. So I stole this slide, and I should have read it more carefully. But and here are the references. The original, the seminal works by Fahey, and I have a criticism about the demonstration that you converge. in my point of view, it converges to a minimum. I can't deny that, because as I showed you, sometimes you sum a bunch of non-negative numbers, you find a minimum. Or you sum a bunch of negative numbers, then you find a maximum. But I don't believe that it's a universal that you converge to the ultimate best solution, to the real ground state. As we showed in the example, we put an answer like a Gaussian, and we could find exactly the minimal energy, the ground state energy for the harmonic oscillator. In that case, we just in the point. But I wouldn't say that it's so general that it will map the best solution for you, but it will give you a good candidate at least. So that's the point. So what I'm telling you, in other words, is be careful with heuristic methods, right? So if you speak Portuguese, I invite you to read our paper. So, I mean, we put a lot of effort to write it well. And this part, the key AOA part, was so well written by Thaisa. So it's very nice reading. And in my view, it's the role paper gives you a broad introduction to the field, but not everything that you have to do with quantum finance. So I have to tell you that we have like a clickbait title. We are overselling what we really do, because there is a lot of things that we can do with quantum finance that we didn't cover, okay? But, yeah, we can read this paper. I also stole it with the guy who asked me about the warm start. Yeah, I think it's him. Yeah, then you can, I invite you to read this paper and then tell me what is this. So, final thoughts, the future of quantum finance. I invite you to read this, some recent paper. They discuss a lot of areas. I didn't mention quantum Monte Carlo approach. How do you make value investment? In the first day, I mentioned that things has a value and things has a price. And people use a lot of Monte Carlo, simulating the future with Monte Carlo, and trying to investigate the value. What's the value of a share from Amazon right now? I can tell you the price. I can open and see the bid price, the ask price, and what's the price exactly now. But what's the value? What's the value? With the same idea that I gave you, what's the value of a car or the value of a house? So you have the idea if it's the price is high or the price is low. So those big investors, they want these analytical models to give them a good estimate to the value of things. So it was not what we did here. So there is a lot of things that we can do with quantum finance related with value investing. And this is a good opportunity. So I invite you to read this paper, and with a final exercise, I'd like you to do this exercise. I already did this exercise, and it's very good to give you an idea, because we are only imagining that the past will repeat. So in the first day I said, invest is about reasoning, is about preparing, thinking about the future. A lot you cannot know. And what's our best guess? We are saying that when you do this portfolio optimization, what you are doing? Okay, with the data that I have now, I have this best portfolio. Should I invest in this best portfolio? If you believe that the future will repeat in some degree the past, then you should invest the same way as you computed. That's the point, that's a clear point. If you imagine that the future will repeat or somehow, there is a saying that the future doesn't repeat, but it rhymes with the past. In some degree, it's more or less related with the past. And I can't imagine how we would best guess the future if not saying that the past will repeat. And do this very naive approach. So if you are thinking seriously about investing and you have a strategy, it doesn't know how better you think you are than Isaac Newton. I gave you Newton example in the first day. Do this comparison. Shift your data one step back and say, the future will be exactly as yesterday. The price for tomorrow is exactly the price of yesterday. Then compute the Pearson error and the mean square error, and test this against your best strategy. Try if you can beat this naive approach. This is very hard. And if volatility is low, if the volatility is low, Pearson is closing to 1, saying that you have a few analytical profitable space. It's very hard to get an analytical model that can beat this approach. So you can do this exercise easily, right? So don't fool yourself with what you get in models or things like that. The naive approach is very hard to beat. That's my point. So it's not our primary research topic. It's something that we did to have a portfolio in this topic, to have a Brazilian portfolio, because we had this idea, okay, what people are doing, let's try to understand. Then we found some space to publish in Portuguese to the Brazilian community so that banks can see what we are doing and some things like that, because this has connection with some opportunities we imagined, but it's not our primary research topic. But I think that you guys can have a look at, there is a lot of space in this field, and especially if you are trying to change from academia to industry, is nice and because it's competitive, you see? It's objective and competitive. Doesn't matter how good you think you are, if the guy just in front of you can have a better model. It's objective. So I like this kind of open competition. You can say, I'm good, and blah, blah. But what's your number? What's the mean average? Or what your profitable or average profitable? So it's a very objective environment, and I like this. And in the end, I'd like to thank you, and I'm open to questions and comments. So questions?
Yeah. So from an industry perspective now, you showed, for example, in the square scenario, you have in the Python multiple ways to solve the problem classically and quantumly, right? Classically, you also obtain the correct result. So from the standpoint of the computation cost, I mean, like how much do you have to invest in hardware or maybe cloud computing? Is there such a scenario in which, for certain scenarios, doesn't matter the accuracy of the algorithm, put that aside for a moment, but given the same algorithm, is there such a scenario where you could say, okay, a quantum computer can perform this algorithm in a most economically efficient way?
Okay. Yeah, this is a good question, and not so easy, but I have an answer for that. If you look at in the code, the time cost, the highest time cost is the quantum, is the classical approach. So it takes longer. But imagine that you have, we use 4 stocks, but if you go to 8 stocks, so to visit this weight vector space, now it's 8-dimensional, you have to sample a lot. That will cost you a lot of computational implementation. So what I see people doing, and why people are doing quantum computation, that they have, you can achieve the best solution, or one of the best solutions, much faster. So you can kind of prepare for changing the environment. So if in the next month you want to include the analysis of a new stock or a new opportunity, or now let's include crypto stock altogether, then you are much better prepared if you have a quantum approach. It will cost less.
What is a quantum simulation?
Even if a quantum simulation, if a noisy quantum simulation. Because those noise, just to get people aware, so you have the real back end in quantum computers. But you have also a simulated back end for that specific quantum computer. So IBM also delivers this, and they calibrate weekly. So it's very close to the real back end. So you have Jakarta back end, and then you have noisy Jakarta. You have Quito back end, and then you have noisy Quito. So that they have, because they have the gates, and they have the gate errors, and then can calibrate how the errors is behaving, and then they give you a simulator backend that is very close to the real backend. So you can have also a guess of what you get if you run a quantum computer using the noise backend. KLM also has the noise backend. They also have a noise implementation of this. But in my point of view, it's recording. I have to take care of what I'm saying. There is no space. I will rephrase. It's much better to invest in quantum access to simulator than buy a simulator. That's the point. Because it's calibrated, you have, you have this quantum computer as a service came to stay. I personally try to move, I'm moving all my things to the cloud. So even imagine in an industry, because yesterday I was thinking, if someone steal my computer, I'm over. My life is there. So imagine this, not to think about your infrastructure, even if you have like a small environment, a small work environment. Imagine if you have an industry environment. Does it make sense? Did I?
Yeah.
So, more questions?
I have a question. I really want to get an insight about the QA algorithm. As far as I understand, here in the documentation and your slides, we have like two types of Hamiltonians: the problem one and the mixing one. I think the problem one is quite direct how to find it, but the mixing one, given a problem, how do you define the mixing Hamiltonian in your
Yeah.
algorithm?
The mixing Hamiltonian is, in my perspective, is the one, I don't have it here, but it's the one that, where is it? I think it's over there. Yes.
I think it's the B one, because the HC is the cost.
Mm-hmm.
Right? So how do you define that, the Hamiltonian?
The point is this. See, here you have entangling scenario. So if you don't have this red one, you are kind of construct something that you can easily replicate with classical. So yesterday someone asked me, is this the best we can have? I cannot tell you that is the best. Any circuit that you can imagine can perform. I mean, you cannot say this is the best one. At least for 3 qubits, we have recently a paper telling that a theoretical, optimal, universal approach. So the point is this, and then I also show the VKE and the others. The point here is that this structure is very close to the idea that we are parameterized with a Gaussian, and then we can arrive. It's easier to differentiate it. You find a minimal easily. That's the main advantage.
The motivation.
This is the motivation. So then you have to repeat this extraction and then try. And then this, the answer to exercise. Then you have to try and see if you understood. It's not exactly the same because here is for 3 qubits, but once you have a good understanding, then you can go up. But I really like this API implementation as well. I really like, as a first guess, to try this that is done for you. Because the implementation cost, you should take care as well. So you can sum 2 plus 2 in assembly, you see? But the implementation cost should be in your cost as well. So I really like to try this vanilla approach. This is done for me, then I will try for free of implementation cost. Then I will adapt if it's better. Because the idea behind this, maybe I'm too lazy, and this is an advice for lazy people. What I imagine, when I go and check the documentation, I always think, I cannot imagine if I could ever get a code like this. So professional coders doing the best thing for me, so I should use. This is my perspective and the approach I always do when I check the documentation. Once in my lifetime, I could beat the documentation. It was back in Fortran, because the guys implement these numerical recipes. Maybe people know what I'm talking. And then in a snapshot of a code, they forgot to put double precision. It was the only time in my life that I could beat a professional programmer. And since then, I be very careful if I should invest time on that. So more questions? Yeah, and a good entry point, the Qiskit documentation is so nice. The documentation by then is so nice. You should follow. If you are entering this field, you should follow at least to get the main ideas, and then you can move. Also, penny learning documentation is very nice. If it's quantum machine learning, you can start with penny learning, but if it's quantum computing, I would recommend to start with Qiskit, IBM tutorials.
prisoner's dilemma quantumly, right?
Mhm.
So where his decisions from a prisoner are correlated with the decisions of the other. So I was thinking if are there some papers on making strategies for investing that, for example, can correlate. Because sometimes when you want to minimize risk and you can buy a spot price and then sell at futures or something like this, you know, and you manage your risk in this way. Are there some references that play with strategies that are correlated in the sense that I make a decision and I make a future decision, and if one happens, then it may change the other one, and how I play the market, for example? Or,
Yeah, I have one. And also I really tried one. In fact, it's this approach is more from the artificial intelligence approach, is that you think that you are teaching your code to play a game where the reward is when you win money and the penalty is when you lose money. So we try to make, to train your code to play this game. So in the end, you have the highest profit. So, but it's really hard to code those kind of, it's not so a legal approach as we can do in supervised learning or unsupervised learning, that you plug this layer, then you put in the top of this layer. The pipeline is so easy. So you can plug layers and say, go and find our approach. Coding this in this approach is really difficult, but people, I have some codes on that I can share if you want. Yeah, I picked from someone in the internet and try to adapt it to Brazilian stock, but not with real money. I always say that, or at least not with your money. Yeah, I was there with Gene Stanley, as I told you, the guy famous for econophysics, and he used it to tell, okay, when you are going to invest a lot, but not your money. So you create a fund, and then I have the best model. Let's use this model with your money. In some sense, I like this approach. You have to be honest about the risk, but I prefer. I mean, I use real money, but in other approaches, I tried some approach in this kind of gamification approach, but not serious money, just small money. More questions? So I will be here until Friday if you guys have any doubts, and I can gladly help you guys. Thank you again.
Eu tinha uma dúvida, na verdade, mas eu vou conseguir